center. There we go. Hi, Sophia. We'll give it a minute and see if anybody else shows up. All right, so I have this down as our schedule as being 10.4, 10.5, the study guide on the 22nd, and then you guys doing the final the 23rd and the 24th. But I'm thinking about changing this review date to maybe down here to Monday, and then you guys doing the final probably May 1st. What do you think of that? Do you think that would be good? Because that would give you guys more time to study and get your work done. That's the reason I'm thinking maybe we should do it that way and change it a little bit. So let me know. Text me down in the comments and let me know. Do you think we should change that? I'm just kind of debating about it. I'm not sure how you guys have been keeping up with the assignments and stuff, so that's why I don't really know. I kind of want some feedback from you guys. Okay, that's what I was kind of thinking. I'm thinking we have an extra week to play with. We don't really need to cram everything in. But I do want to do 10.4 and 10.5 this week, so you have everything you need so you can study for the final and stuff. And we'll go over the stuff for the final on the 27th, and we'll go ahead and change that. So you'll still need to do the surveys and stuff on your own, but we can talk about that next week too. I'm not sure. There's an ACT bonus, and I don't know how that's going to play out yet. They're still trying. That's the last thing that they had to figure out. Okay, so we will move the finals. I think we should just move them to May 1st. Final 1 and final 2. And that way everything's due on the 30th. All the homeworks are due. All the labs are due. All the quiz links that WVU requires will be due then too. Alright, well let's go ahead and get started. This is 10.4. This is vectors. All right, so the first thing we're going to start with is what is a vector. So a vector is a quantity that has both magnitude and direction. And we notate the vector as a V with a little, like, half of an arrow on the top of it. So this is a quantity that has both magnitude and direction. Okay, and we represent this by an arrow. Now, when you're looking for vector in the book, it's going to just be a V with bold font. But since you can't really bold your font when you're writing, we use the V with the arrow on notebook paper, but they'll just have a really bold V in the book. So this is represented by an arrow. I'm just going to squeeze that in right there. All right, so magnitude, that's the length of the arrow. And direction, that's the arrowhead itself. All right, so here's what a vector looks like. It's just a dot with an arrow, and a lot of times it will end on a dot. Some books leave out that dot, but some books put it in. It just kind of depends on the notation of the book, but ours puts a dot at the end of it. So this is the point P, and this dot over here is Q. So Q is called the terminal point. That means that's the end. And P is the initial point. Okay, so we would name this as vector V, which this is also named PQ. So capital P, capital Q, and then it has an arrowhead over the top. All right, so for this, you're going to need some notebook paper also. Or not notebook paper, some graph paper. So if you don't have your graph paper, you're going to want to get some graph paper. All right, so vectors, you can add vectors, and it's the same thing as adding any two numbers. 2 plus 3 is 5 is the same thing as 3 plus 2. So they're cumulative. They have the associative properties. So if you would put parentheses around these things, then it would also be the same. So vectors are commutative. Which means if I had a vector V plus a vector W, that's the same thing as vector W plus a vector V. All right, they're also associative. Which means if I had a U plus a V plus a W, that is the same thing as moving the parentheses around the first two things. U plus V and then add the W. They also have a zero vector. So that just means that a vector v plus the 0 is the same thing as just v. And you can flip this around because it's also commutative too. So 0 plus v would give you vector v back again. All right, now they also have this other property where if I had a vector v plus negative vector v, so this is exactly what you would think. 2 plus negative 2, it works the exact same way as regular numbers. So that would just give you a 0. Okay, so this means v goes one way. Negative v means the arrow changes direction. So they have the same magnitude, but they go in opposite directions. So you're kind of looking at, okay, this one's going this one, and this one's going to go the opposite directions, and those are going to cancel each other out. That's basically what that's saying. And you can also have scalars. And scalars, I just think of that as just a regular number that you're timesing like in front of your x or whatever. We'll get to that on the notebook paper here in a second. It'll make a lot more sense. But they're just real numbers that only have magnitude. Okay, so for life examples, this would be temperature. Okay, temperature does not have a direction. It's either hot or it's cold, or in between, you know. But it's not really going in a direction. Speed would be another one. Okay, you're either going fast or you're going slow or you're going in between, but the speed itself doesn't really have direction. And then time would be another one. You're either in the past, the present, or the future, but it doesn't really have a quite direction, you know. Okay, so we have 3 cases that could happen, and these actually make complete sense. So alpha is going to be our scalar. If that is greater than 0, you'll have your alpha times your vector. And basically what happens is that they're going to go in the same direction. Because this is positive, and so this is kind of like a positive times a positive. They're going to both stay in the same direction. All right, so if I had it less than 0, then you could think this is negative times your vector, and it's going to make the direction change. So it's going to go in the opposite direction. So that just changes the arrowhead. And then the last case is if it equals 0. So if you're doing 0 times your vector, it's the exact same thing in real life that you would think of. So it's just going to be 0. So if you had your alpha times your vector, and either the vector 0 or the scalar 0, it doesn't matter. It's just going to give you 0 at the end. Okay. All right, we're going to jump to our graph paper. And if you have your textbook, it probably would help to have that out at the same time. So you can kind of look at the pictures in the book as we're working. We're going to be on page 768 in the textbook. All right, so we're going to jump here, and I'm going to show you where we're going to actually add the vectors in here. And we'll do the scalar times the vector. So you'll actually see it more visually what it looks like. It's different, but it's not difficult. So that's the good news. All right, so I'm going to my graph paper. If you have graph paper, that would be really good to write on it now. I'm just starting on any box in the bottom left corner. I'm going to skip a dot going diagonal, and then I want the arrowhead to end on the second one. Okay, so I started here. I kind of put a dot there just for a placeholder, and then that's going to be the arrow. We're going to connect these all together. Okay, so this is my vector V. And now what I'm going to do is I'm going to do 2 times V. All right. So to do 2 times the vector V, it's basically, you're going to draw 2 of them together, basically. So we're going to start here. And then here would have been my arrowhead, but I'm doing 2 times it. So I'm going to go skip a dot, and then here's going to be the end. Okay, so here's the original 2V right there, and now here's the times 2 part, so you just get 2 of them. So that's 2V. All right, now we're going to do negative V. So for negative V, it's going to look exactly like the first one. So I have my starting here, I'll skip, and then here would be the end point. Now since I'm doing negative V, the direction's going to change. So I'm really going to end down here. So all that does is flip the arrowhead. So now here's my start and here's the end. All right, I'm going to give you a different vector. I'm going to call this vector W. I'm going to start down here. I kind of think of this as slopes because it's easiest to explain. So we're going to go up 1 and over 2. So we're going to go, oh, wait, I think I said that way wrong. Up 3 and over 2. So up 3, 1, 2, 3, and over 2. Right here. Here's going to be our end point. So just start from your dot. Go up 3 and right 2. This is going to be what I'm calling vector W. So now what we're going to do is we're going to add vector V and vector W together. So the first thing we're going to do is we're going to start with vector V, and we're going to draw that one on there. I'm going to start a little bit lower so that I have enough space to put the whole thing on there. So I'm going to start with vector V. So I'm going to go my diagonal and then my second. So here's my vector V. And I'm going to add to that vector W. So vector W is going to start right here. And we're going to go up 3. 1, 2, 3. And right 2. So here is vector W. We'll get a ruler in here, maybe make this a little bit neater. Okay, so this is my vector W. Now the V plus W is from here to here. So this whole thing from here to here is going to be your V plus your W, which is the answer that you're looking for. Here to here is really skinny, but this is the answer. Okay. All right. All right, so we're going to use the book again on page 768, and I'm going to be doing number 14. So what they do is they give you a diagram of a W, a U, and a V, and they want you to draw out the answer, and they want you to draw out 2U minus 3V plus W. Okay, so we're going to do 2U minus 3V plus W. All right, so the first thing I'm going to do is, in case you don't have your book with you, I'm just going to draw out the W, the U, and the V original before we do the actual answer. Okay, so W is going to start down here. 1, 2, 3, 4. We're going to go up 5 and right 2. 2, 3, 4, 5, and right 2. So here's our W. All right, U, I'm going to start right there, and I'm going to go down 1 and right 2. So that's the U vector. And the V vector is just a straight horizontal line. 1, 2, 3, 4. Just going 5 across. 1, 2, 3, 4, 5. Okay, so this is the V. So this is what they give you originally in the book. So you want to start over here. We're going to do 2U. We're going to draw that first. Then we're going to draw the minus 3V and then the plus W. And then the connecting part together is going to be the answer on there. Okay, so we're going to start with 2U. So I'm just going to start somewhere over here. I already know what the answer looks like, so I can kind of cheat in advance, if you could say. So I know you're going to need to be further over on this side of the paper. Okay, so I'm just going to pick a spot over here on the far left of my paper, and we're going to draw 2U on there. So I'm going to go down 1 over 2, and then down 1 over 2. And we'll connect those together. So that right there is 2U. And then we're going to do a minus 3V. So the minus means the arrow is going to be over here on the left instead of on the right. And I'm going to have to draw 3 of these things. So this was 1, 2, 3, 4, 5 boxes. So I know I need to go 15 this way. So it's best to count in groups of 5. So 1, 2, 3, 4, 5. Here's your first 5. 1. I'm just going to put a little tick mark there. 1, 2, 3, 4, 5. There's the second 5. 1, 2, 3, 4, 5. All right, there's the last one. So there's your third group of 5. So that's our 3V. Okay, and then the W, I just need to draw that how I have it. So there's the dot, and I need to go up 1, 2, 3, 4, up 5 and right 2. 1, 2, 3, 4, 5, and right 2. So there's my W. This dot technically should be on that blue line. Wow, even with the ruler, I can't draw it straight. Okay, so from here to here, that is the answer. Okay, so we're going to connect these together, and then we'll have our answer there. Okay, and we'll just draw our arrow on there. So we're connecting the 2U when it ends at the 2W. So the W is the one that gets the arrow because we start here at the 2U and we end at the W. So that's why the arrow is pointing this way and not towards that way, because this was the starting and this is the end. Okay, the next one we're going to do is 21 and 22 in your book, and I think I'm just going to not draw this out and just show you the book thing, because it's just easier to see what the book has done. So we're going to be using this diagram right here in the book. We'll just do 22. Zoom this in a little bit better so we can see the book. All right, we're using this diagram right here. So 22, this is, I think, just true and false, really. So we'll start with, we'll start with 21 and then we'll do 22 after that. So we'll start right there with 21. So 21 says, and you'll notice it's just bold in the book. So it's basically vector A plus vector B plus K plus G equals 0, and you're just putting down a true or false. Okay, so you're just going to follow this thing around. So here's A, there's B, there's K, and there's G. So you'll notice it just makes this little rectangle right here. So it's 0, so this is true because it starts and ends on itself. So there isn't a place where it connected, like here we actually had a red spot here to connect. So this is true. So that's true because it starts and ends in the same spot. Okay, so that one is true. So it starts and ends in the same spot. Okay, and then we're going to do 22. So 22 is saying A plus B plus C plus H plus G equals 0. Okay, so we're going to follow this around. So A, B, C, H, and G. So again, that one's true because it starts and ends on itself. I'm going to leave out the reason on this one because I feel like since it's the exact same reason as above, you should at least kind of understand it more this time around. Alright, so now we're going to go back into our book. We've got a few more definitions, and then once we get through those definitions, then the problems make way more sense, and it's really not that bad. This is not a bad section at all. Okay, so I think we have about 3 or 4 more definitions per se. It's probably the worst part's the definitions. Okay, so we have an algebraic vector V. So vector V is going to be represented by A comma B. And these are greater than and less than signs. Okay, so A and B are scalars, and they're called the components of vector V. Oh, I forgot the beginning part. This is called an algebraic vector. Okay. B are scalars. So scalars just meaning they're numbers, basically. Okay, so this is just a definition. So an algebraic vector is the A, B, where A and B are just scalars, and we call those components. So basically, we can use rectangular coordinate system to represent algebraic vectors in the plane. Okay, here's a theorem. Okay, so suppose that we have a vector v. So v is a vector, and we have an initial point of P1 and a P2. Okay, so P1 is x1, y1, and P2 is x2, y2. Good so far. This isn't the end of the... It's not the end. I'm just trying to give you time to write. Okay, so it says if vector v is equal to P1, P2, that vector, then v is equal to the position vector. Then v, not P, v. Okay, so what you do is you take x2 minus x1 and then y2 minus y1. And I think of this as just like slopes. That's how I remember this, is it's just like the slopes. So you just do x2 minus x1, y2 minus y1. And we got 2 more definitions to go. And then I think 4 problems and then we'll be done. All right, so any vector v which is a comma b, can be written using unit vectors. And this is I, vector I, and J. Of course, they have to get dyslexic people the 2 worst letters in the alphabet you could pick. As follows. Okay, so V is A comma B, and that's the same thing as basically AI plus BJ. Okay, where A does the horizontal and B does the vertical. does the vertical components. You won't have to memorize these definitions per se. The next one that we do, you will need to memorize for sure. I mean, it's a promise that magnitude's going to be on your final. So these ones are just kind of setting you up for the next one, which is the really important one. All right, I'm going to have to move to the back now. Okay, so this is a definition. These are the ones that you're going to want to know for the final. These are the ones that's going to be the important ones. Okay, so let vector v be equal to a1i plus b1j, where b and j are like the vectors. Okay, and you could rewrite this as a1 plus a2i all right. All right, and B is also, or W is also a vector. So A2I plus B2J, and that could be equal to A2 comma B2. That part's not as important. This part over here, this is the important part. This stuff, not really. Okay, those are your two vectors, and alpha is a scalar. Okay, here's the part that comes into being more important. All right, so you can add the two vectors together, and this is way easier than it looks, okay? So you could separate these out like that, and same thing with the B, I just didn't really write it, but it's A1 plus the A2, so you would just add these in the front, and that would give you your I, plus B1 plus B2, and that gives you your J. So when you go to actually do these on paper, it's going to be really easy. You're just going to take the two front numbers, add them, take the two second numbers, add those separately, add an I, add a J, and you're done. Okay, V minus W, all you're going to do is just subtract the numbers from the front. So A1 minus A2I plus B1 minus B2J. Okay, then your scalar times a vector, you'll just have to pick one or the other. They're not going to make you do both. So you would just times that by the front number, your A1, and then you would have to times that by your second number. Not B, that should be a B1. And that's your J. J. Okay, so you'll just times it by the first one and then times it by the second one. All right, and this is the one that's the most important out of all of them, is the magnitude. If you only remember one, by God, let it be the magnitude one. That's the one that's guaranteed on the final. So it will have double bars around it. It'll look like absolute value bars. Okay, and that is equal to the square root of a1 squared plus b1 squared. This is definitely the one I would memorize, for sure. I haven't looked at the final recently, but last year's final, I think there was at least 2 or 3 questions on magnitude between both the first one and the second part, because you have to do 2 parts in the final. All right, we're going to jump back to the book, so this is going to make a whole lot more sense. I hate doing definitions because I feel like they never make sense until you actually do the problems. Okay, so this one is actually number 26 in your book. So this is what you'll do for 25 to 32. Okay, so it says write vector v in the format of ai plus bj, that is found, that which means find its positional vector. Okay, so they're going to give you some coordinates. So P is 0, 0, and Q is -3, -5. All right, so to find the positional vector, all you have to do is add the 2 first numbers and then add the 2 second numbers. So you're going to add these ones together, and then separately you will add these ones here together. All right, so our vector v is going to equal to -3 plus 0, and that will be your I, plus your -5 plus 0, and that will be the j. So -3 plus 0 is -3. So this is -3i, plus -5 plus 0 is -5. And that's your answer. So like I said, the actual problems aren't that bad. It's just all the definitions are terrible to get to do the problems. Okay, the next one we're going to do is 36, and this is for 33 to 38. And this is pretty much a promise that this will be on the final. This one's pretty much guaranteed on the final. Okay, we're going to actually do number 36. Okay, so they are saying that vector v is equal to -I minus j. And what they want you to do is they want you to find the magnitude. Now on your final, I think he words it several, because he puts multiple questions of this exact same concept on there. I think one of them, he just uses the notation, just like this. So one question will be worded like that. Then the second one, of course, he will change these numbers, but he'll change the definitions where it says, find the magnitude. So he'll ask it 2 different ways. But it's the exact same concept for both of them. So you're going to need to know this concept, and it will have the 2 double bars. So that's your giveaway. Look for those 2 double absolute value bars. And magnitude, they mean the exact same thing. Okay, so the absolute value of V is equal to, and I like to write the definition out, it forces me to remember it. So that's A1 squared plus B2 squared. Okay, and you're just picking off your numbers off the front. So this A1, so this is A1 is -1. Your B2 is -1. So you just pick off the coefficients off of A goes with the I and B goes with the J. So you just pick them off. So this is the square root of -1 squared plus -1 squared. So -1 squared, that's 1 plus 1. So your answer is the square root of 2. Okay, there's one more definition. I guess I lied about the definitions. 2 more problems, 1 more definition. This one is on the final also, I believe. Okay, so how did they? I'm trying to figure out what the definition is for this one. So this is just a theorem. It's called unit vector in the direction of V. Okay, you can find this theorem on the top of page 765. So for any non-zero vector, V, okay, and then here's the definition part. The vector, so here's going to be it, U, this is a U. Okay, so the vector U is equal to the vector V divided by the magnitude of vector V. This one is also on the final. I remember seeing that one on the final also. Okay, this is a unit vector that has the same direction as V. All right, so we got 2 problems left and then we are finished. So we're going to start with number 46. So this is going to be for numbers 45 to 50. We're going to start with 46. So it just says find the unit vector in the same direction as V. So anytime you see one that says unit vector, this is the theorem you're going to need for unit vector. So this one is the unit vector. All right, so they give us V is equal to -3J. All right, so our definition, our unit vector is going to be the vector divided by the magnitude of the vector. So we're going to put negative 3j on the top, divided by, and then the magnitude was that formula, the square root of a1 squared plus b2 squared. Okay, so since this is j, this one, the negative 3, has to be the b. I think it's b1. Isn't it? I put b2. They're both from the same thing. So a is 0. So this is negative 3j divided by the square root of 0 plus negative 3 squared. Okay, so negative 3 squared would be 9. So this is negative 3j divided by the square root of 9. The square root of 9 is 3. So negative 3j divided by 3. And that gives you negative j as your answer, because the 3 is reduced. Okay, and then we got one more problem and we're done. All right, number 50. So vector v is equal to 2i minus j. And they want you to do the exact same thing. So they want you to find the unit vector. So the unit vector is vector v divided by the magnitude of v. So you just write down the vector they give you, 2i minus j, divided by the square root, and then this is going to be, this is your a, so 2 squared, and then that's your b is negative 1, negative 1 squared. Okay, so 2 squared is 4, negative 1 squared would be 1, so 4 plus 1 would be a 5, so that's the square root of 5 on the bottom. Man, I'll tell you what, after a while, those little arrows on the top feel like they get annoying. All right, now you do have to simplify this. You cannot leave the square root of 5 in the denominator. So we're going to need to times top and bottom by the square root of 5. Okay, so distributive property here on the top with both of these things. So I get 2 square root 5i divided by 5. Oh, I made a mistake on here. Look, I just turned a minus into a plus for no reason. That should be a minus. I hope you caught that at home. Okay, go back and make that be a minus, because the minus should not have turned into a magical plus. It doesn't work that way. Okay, so this should be minus the square root of 5j divided by 5. And that would be your answer. All right, so that is it for the problems. If you were late walking in today's class, we decided that we're going to do 10-4 and 10-5 tomorrow. We're going to push that review day to Monday. So we'll have another one tomorrow, and then we will do Monday. And then that pushed your final, I think, to May 1st. Okay? Which means this week you need to do Lab 10. You also need to do all of the homework quizzes. Okay? And Friday is the last day to drop the class. So if you want to drop the class, the 24th would be the last day to drop classes. So just keep that in mind. We're so close to the end that I don't see anybody would want to drop. But if you would want to drop, Friday is the last day to drop. All right, I'm going to look at the comments. Do we got any questions? Oh, Lucas, you did catch me changing signs. Good job. Did I get a refund for my taxes? Yeah, my tax refund came in. Oh, do you mean if you drop the class, do you get a refund? No, if you drop the class by Friday, you don't get a refund for dropping the class. Is that what we meant? Yeah, sorry, I didn't understand what you meant when you said, do we get a refund? No, unfortunately, if you drop the class, you do not get a refund. They're going to keep your money, and then they'll put a W on your transcript, and basically you would have to repeat the class next year if you still need the class. And then you would not be guaranteed into calculus in the fall. If you would need to take calculus for your major, you would have to have that ACT, which right now is going to be very hard to get because I don't know. I know they canceled the April ACT, and I think the June and July are still a go, but we're just playing it day by day. Nobody knows how that will go in the long run. So does anybody else have any questions or comments before we end the live stream? Just make sure I get a picture of your test 4, because I know that I got one from Cameron and I haven't gotten anybody else's picture for that, and I need your pictures of what we scored for on test 4. So make sure you screenshot or take a picture of your test 4 for me. All right, well, I guess there's no more questions. I will see you tomorrow for 10.5 again at 12:30. And then we will meet again on the 27th for the last day of our live videos. All right, well, you guys have a good day, and I will see you tomorrow at 12:30.